Two common items in a powerful new way. I told my readers to harness the cleaning power of ammonia with the whitening power of bleach.
Ammonia and bleach? You told people to mix ammonia and bleach?
Only if they want bathroom fixtures that shine like the sun.
Peggy, that's the recipe for mustard gas.
And so, one of the most common myths in chemistry is that combining ammonia and bleach, as illustrated here, makes mustard gas. But actually, this is not true. And we're about to bust this myth wide open. And so, in reality, what combining bleach and ammonia actually makes is a chloramine gas of NH2 and chlorine and sodium hydroxide. And so as you can see, this is not the same as mustard gas, which does contain chlorine, but is actually also contains a sulfur. And so, although both of these gases are very toxic, the chloramine here is chemically different from this mustard gas. And other examples of this are seen between other household items in which you can make dangerous chemicals from the things that you use to clean or disinfect yourself and your house. Bleach and alcohol, for example, which I will draw here. Isopropyl alcohol, that is, combine to create chloroform. Something you would not entirely expect out of your household items. And bleach and vinegar combine to make chlorine gas. Something that is also mistaken for the chloramine made by ammonia and bleach, as well as water. Peroxide and vinegar can combine to create peracetic acid, which is also a highly corrosive substance and very dangerous for humans to touch or ingest. But what is the significance of this for our organic chemistry? Well, it uses mechanisms that we've seen before. Because as seen with this ammonia and bleach reaction, when you combine the two, much like a sodium ester that we've seen before, the two combine in such a way that leads to, rather than the alkylation of an amine, it leads to the chlorination of an amine, in which we reform the original base now as sodium hydroxide, with the sodium being a spectator ion or spectator material, while forming the NH2Cl. And this goes on to be even more dangerous because as you repeat this process, there's still leftover bleach, which will continue this process, taking another hydrogen and then allowing the nitrogen to take another chlorine, and so on until you have 3 variations of this nitrogen, as we have seen in our own class through the alkylation or even hydration of a nitrogen group, in which it goes from being a primary amine into a tertiary. And so, as you can see, even among these reactions, we have similar mechanisms to what we've done in class, with this one involving the halogenation of a methyl group that creates a better leaving group from this very isopropyl alcohol, in which the bleach here exchanges the hydrogens for one of the hydrogens around these carbons for chlorine. With bleach and vinegar, we see a protonation of the hypochlorite, also known as bleach, into a hypochlorous acid, which I've not drawn, but which eventually allows for the reaction of the loose chlorine ions to form chlorine gas and also the leading group of water. And then with peroxide vinegar, we see something that almost looks like a Baeyer-Villiger reaction, but in which the carbonyl here, as we've studied, electron-rich area, electron-poor area, is attacked by this oxygen and allows this hydroxide group to leave, creating this, and also from the protonation of the hydroxide group, H2O. And so, as I've explained, the myth of bleach and ammonia creating mustard gas has been busted. And so, you can tell it makes neither mustard gas, nor does it make chlorine gas, but rather a chloramine ion in multiple variations that is very harmful to your lungs and skin and respiratory system and body in general. So it's a bad idea to mix those, as Peggy Hill so helpfully explained with the help of her husband. Goodbye.
You have a question from the audience.
What is that?
How do you make mustard gas? And can I do it in my bathtub?
I'll have to look into that.